Bismillahirrahmanirrahim. Assalamu alaikum everyone. Today we're going to be learning lesson number 8, and this is called Polynomials and Synthetic Division. It's split across 2 assignments for us. You're going to find this to be a relatively straightforward lesson that's going to teach you a lot about polynomials. It sums up a lot of things from middle school algebra, 9th grade algebra, Algebra 1, Algebra 2, and then pre-calculus. So it's like 4 lessons in one. It teaches you everything about polynomials that you'll need to know in this course and beyond. So let's go ahead and get started. First and foremost, I've linked this in the lecture notes themselves, and it's also on the website. This right here is kind of your cheat sheet. Some things have been discussed before, some things have not. These are all different kinds of formulas that we'll be needing for this lesson. And inshallah, I don't want to run you through every single one of these. What I'll do as I proceed through lesson 8 part 1 and then lesson 8 part 2, I will refer back to this little sheet right here. That'll really help you to keep track of what type of formula are we using. I'll just give you one idea though. The whole purpose of having these formulas is to basically save us a whole bunch of time, okay? Just to give you a quick example of what I mean by that, if for instance you take a look at this formula that says the cube of sums formula, right? If you take a look at that formula, it says a plus b whole cubed. If you don't learn the techniques to actually do this using some quicker way, which I have for you today, this is actually what you would end up doing. You would end up using the FOIL method on that part right there, and whatever answer you get from that, then you'll have to multiply it further to a plus b, and that'll lead to even more work, right? It can be done, but we're trying to find ways to cut down our work, not to make things more for us. So let's go ahead and get started. So the first skill that we need to learn is to tell whether a expression is a polynomial or not. Like, how do you even know you're looking at a polynomial? So here is the general format that we give to students to tell if something is a polynomial, all right? If something is going to be a polynomial, it's going to be written in the format. Now, initially, this is going to seem really different to you. It'll have most likely a number out front. Let's call that number a sub 1. And then it'll have most likely a variable like x. And you can call that x to the power of n. And then if you have another term, it might be a second term, a second coefficient, and it will be multiplied to x, and perhaps the power on it will be a little less than before. And so like this is the general format that we give to students, and we say this is basically a polynomial. Now I know initially that seems pretty crazy, going like, what is that exactly supposed to be? So what we're going to do is we're going to keep this up here as we work through a handful of examples to tell if something is a polynomial or not, right? This is just a rough format of what a polynomial would look like. And then as we go through these questions, we'll talk about what a polynomial does not look like. And at the end, the hopes is that you'll be able to tell very quickly whether something is a polynomial or not. Now, if it is a polynomial, another thing that we're going to do is we're going to talk about its degree. Okay, we're going to talk about what the degree of that polynomial is going to be. And if it's not a polynomial, of course, we'll talk about why it's not a polynomial. So let's go ahead and start with number 22. Number 22 says that you've got 1 minus 4x, right? 1 minus 4x. So this right here is a very good definition of a polynomial, all right? That right there is a polynomial. Now, if you ask, how exactly is that a polynomial? Well, you can notice that there's a number 1. There's nothing wrong with having a number 1. and then you'll notice that there is a -4, or if you want to call it a 4, sure, why not? And it's being multiplied to the x. So that's perfectly good, and this is considered a polynomial. Now, beyond us calling it a polynomial, since we know that it is a polynomial, another thing that we have to tell is its degree. So the degree of this polynomial is equal to 1. So this is a first degree polynomial. And the way that we tell the degree on a polynomial is we look at the highest power of the x that's there. And because there's only one x there and the power, the exponent on the x is a 1, this is a first degree polynomial that you're looking at right here. Okay, let's try another one. Let's go to Bismillah, number 24. All right, number 24. And number 24 says, actually, let's try number 23. All right, let's try number 23 here. So number 23 says that you've got the number 5, right? You've got the number 5. Is the number 5 a polynomial? Yes, you can have just numbers. There's nothing wrong with that. They can be polynomials, right? So if it's just a number, it's fine. It's a polynomial. The degree on this, notice that there are no x's, right? There are no x's. So if there is no x, there is no power of an x. And therefore, this is called a 0th degree polynomial. If that doesn't make sense to you, think of it this way. 5 times x to the power of 0, right? So the degree, the exponent on the x is a 0, and therefore we call it a 0th degree polynomial. That usually helps students to wrap their mind around that. All right, let's take a look at number 26. Number 26 says 3 over x plus 2. If you want, you can rewrite this as 3x to the power of -1 plus 2. And this one is not a polynomial. All right, this is not a polynomial. And so one thing that you come to the conclusion about is the degree cannot be negative. Okay, there cannot be, you can't have negative degrees. All right, it can only be a 0th degree or a positive degree. So if we go up to our table, to this little diagram that we had made, and we add a little bit more, it'll make sense to you. We can say that n has to be a value. So these n's over here need to be giving you something that is going to be greater than or equal to 0. If it's not greater than or equal to 0, it's not going to work out for you. All right, so we've added a little bit more to that. So now you know that one of the things that you can't have is a negative degree. And what I usually tell students is whenever you notice, right, this is the informal way of looking at it, whenever you notice there is an x, right, there's an x or an x squared, whatever, in the denominator, that's not going to work for you. Because if you were to bring that x to the top, then it would have a negative exponent on it. So x's in the bottom are a big no-no, and therefore this is not considered a polynomial. All right, so we've done 22, we've done 23, we've done 26. Let's continue. Take a look at number 28. Number 28, again, all of these are just kind of teaching us a little bit more. That's why I'm sticking to do as many as possible. So this right here, what do you think? Does that look like a number multiplied to a variable? And it certainly does. So what we're going to do is we're going to conclude that this right here is a polynomial. Its degree, right? So it is a polynomial. That's a yes. Its degree, remember, you have to pick the highest power on the exponent. So there's a z to the power of 2, and there's a z to the power of 1. You pick the highest one, and you say that the degree is 2. And how we speak about this is we say this is a second degree polynomial. A second degree polynomial. And one thing, if you think about it, we've been calling these quadratics for the longest time, right? So a quadratic function is nothing more than a second degree polynomial. It's just a way of saying the same exact thing, right? And so let's continue moving to the next one. The last one says that you have well, I don't really need to write it much. Okay, let's just think about number 30 here. Why is this not a polynomial, right? So why is this not a polynomial? And it's very simple to tell that there's a lot of x's in the denominator, right? There's an x squared, there's an x. Those cannot be there, and so that means it's not going to be a polynomial right there, right? So one last thing that I will mention about polynomials before we move on is I explained to you how n has to be something that is greater than or equal to 0, right? We talked about how it's always got to have a positive exponent. And another thing that we'll say is that the n has to be an integer, all right? The n has to be an integer and more like a positive integer. So this kind of sums up what I've been trying to get at. And what I mean by that is if you were to have something like 3 multiplied by the root of x plus 2, this would also not qualify as a polynomial. And the reason why is you're coming fresh off of a lesson that talks about this is root of x is actually x to the power of a half plus 2. And a half is not an integer. Okay, an integer is any number that's a negative or a positive. So -2, -1, 0, 1, and 2. And when I'm saying that they need to be positive integers or 0, then that means they can only be these things over here. They can only really be kind of like those whole numbers, right? So so this is a scenario of where it would not be a polynomial, right? Other things that you might notice, and you should know that they're not polynomials, if you ever see something with an absolute value of x, right? Absolute value is also not considered a polynomial function, so that's thrown out as well. There's no absolute values in that format that we just discussed. Okay, now, so that's a relatively small objective, is for you to be able to tell if something is a polynomial or not. Now what we're going to do is we're going to focus on figuring out how to add, subtract, multiply polynomials, and then in a little bit, that's what's probably going to take the longest amount of time in this lesson, is we're going to practice with dividing polynomials. Now usually I have found in the past that the beginning part of this exercise is relatively straightforward for most students. So what I'm going to do here is I'm going to just take number 36 and just make sure that you know how to do stuff like that. So in number 36, instead of writing all this down, it says 8 multiplied by everything in this parenthesis minus 6 multiplied by everything in the other parenthesis. And so the way that you really begin with this is you multiply the numbers that are out front, right, into the parentheses. This is called the distributive property, right? So you're going to multiply each of these sets, and once you multiply them, you'll basically be coming up with an expression, right? So I want to keep this canvas clear. I don't want to show any work on it, otherwise I can miss something. So here's number 36. Here's the results that we start getting. 8 times 4x cubed is going to give you 32x cubed. 8 times negative 3x squared is negative 24x squared. 8 times negative 1 is negative 8. All right. Then here's a common mistake students have made in the past. This negative sign belongs to the 6, right? So when we say 6 times 4x cubed, that's not completely the best choice. We should say negative 6 times 4x cubed. And so we'll have negative 24x cubed, like that. And then we'll have negative 48x. And finally, we'll have positive 12, right? Because a negative multiplied in is going to switch the signs on all 3 of the terms that you're looking at on the inside right there. And then finally, the last thing that you do is you combine like terms. So notice that 32x cubed can be combined with negative 24x cubed. And so we'll end up with, bismillah, 8x cubed in that situation. Then the next one you can combine is negative 8 and positive 12, right? Negative 8 plus 12 gives you a positive 4. So we'll put positive 4 in just a moment, but just kind of keep in mind that that's the addition of those two. We generally like to write polynomials in a standard format, and the standard format is to start from the highest power of x and then proceed to the lowest power of x, and that's what they mean by express your polynomial in standard format. And so here is your final answer, right? So there's a lot of myths and things that students make mistakes with in this lesson, and that's okay because, it's been a while since they worked with polynomials, but you're going to be working with these pretty much on a daily basis. So, this is just your first snapshot. While we're here, let's just talk about what degree polynomial this is. So notice how the highest exponent is a 3. So this is called a third degree polynomial. Okay, this is called a third degree polynomial. So that's really subtracting polynomials, and adding polynomials is not a whole lot different. You can take, any one of these other questions here, like number 38, and try it by yourself. But usually I've found that 31 through 40, they're never really a problem for anybody. Okay. Even then, let's just take a moment and try number 40 and make sure you're all good with it. So number 40 says 4x squared multiplied by x cubed. So 4x squared multiplied by x cubed is actually going to give you 4x to the power of 5. 4x squared times negative x is going to give you negative 4x cubed, like this over here. Bismillah. 4x squared times 2 is going to give you 8x squared. And you're done with it. There's not much you can do. You can't combine any terms because nothing has an x to the power of 5, nothing has an x to the power of 3, nothing has x to the power of 2. They're only just one in themselves, right? And so looking at the highest degree, we're going to call this a fifth degree polynomial, right? So what I am just hoping is, even if that previous exercise was not very clear to you about what is a polynomial, the hope is, as you're looking through all these questions, you'll develop a pretty solid idea of what a polynomial is supposed to look like. All right. Let's go ahead and proceed to number Bismillah 48. All right. And quite honestly, that's the only one I need to do. Usually students are understanding this part really well. So number 48 says 3x plus 2 times 3x minus 2. All right, so number 48 says 3x plus 2 multiplied by 3x minus 2. Now, you may remember from the lesson on nth roots, all right, that I taught you something called a plus b and then a minus b. And I had even said, I believe it's been a while, but I think I said that I will officially tell you how to work with this in some time. So first off, let's write down that there's two methods to do this, all right? But the method I want you to be able to use in pre-calculus is method number 1, and you may call the first method a squared minus b squared method, okay? And the other method is the FOIL method. So before I proceed with that, let me just travel up here and highlight for you the first formula that you need to be an expert with. And this formula is called the difference of squares formula. Okay, the difference of squares formula. And it basically says that if you have something that is a added to, right, so a, and then it's added to b, and then it's subtracting b, right? And in the middle of those two, you have a plus sign, and then you have a minus sign. So basically, students generally say a plus b, a minus b. Well, the answer to that automatically, the answer to that is going to be a squared minus b squared. Don't spend too much time thinking about it. Just go ahead and write it in and move on, all right? I understand that this is written in the format of a squared minus b squared equals this. You'll understand eventually in the next part of the lesson why we write that. But for now, what I'm trying to explain to you is be able to make this connection very quickly. And then I'll also explain to you what I mean by there is no such thing as a squared plus b squared formula. But for now, you don't need to dwell too much on, why do you say that there's no a squared minus b squared formula, right? Because it won't make an incredible lot of sense to you right now, but it will eventually. All right, so having said that, in number 48, here is what you are expected to be able to do. You're expected, as part of a pre-calc student in the future, your job is to look at the problem that I have in number 48 and say, well, because that's of the format of a plus b, a minus b, I can use the difference of squares formula, and I can write down that the answer is actually 3x squared minus 2 squared, and that gives you 9x squared minus 4, and that would be the answer. See how quickly I did that? All right. Now, if you were an Algebra 1 student or an Algebra 2 student, here is what would be acceptable from you, is you could say that I'm going to use the FOIL method or the rainbow method or the box method, different names for it. But basically, you multiply the 3x and the 3x, right? That's going to give you 9x squared. Then the 3x and the negative 2, so that'll give you negative 6x. Then the 2 and the negative 3x, the 2 and the 3x will give you positive 6x. And finally, 2 times negative 2 gives you negative 4. And notice how the middle two terms are going to cancel out. And that will happen every single time, right? So every single time that will happen, and that's how we actually came up with the a squared minus b squared formula. But we're trying to cut out these additional steps because you have to use this so often in pre-calc that you don't have time to sit there doing FOIL method with it. Okay? All right, now let's go to a different question, number 50 here. Number 50 is going to be teaching us another formula, okay, that you need to know quite well. And so let's take a look at number 50. Number 50 says x minus 5 to the power of 2. Now let's go over misconceptions that your class has made in the past. And back then it was okay. It was okay to let it go. But now it becomes a pretty serious matter if you're making these mistakes. Here's what it's not equal to. This is not equal to x squared minus 5 squared. That's not true. Okay, it does not work that way. And the best example I can give you is pretend if x was equal to 7. Just think about it, right? So if x was equal to 7, 7 minus 5 squared would have given you 2 squared, and 2 squared is equal to 4. Whereas if you had made this incorrect connection, you would have said that x minus 5 squared is the same thing as 7 squared minus 5 squared, which would have given you 49 minus 25. And 49 minus 25 is certainly not 4, right? It's more like, it's like 24. So you see how those two numbers are not the same. And because those two numbers are not the same, this is a very improper connection that students make. And of course, I understand where they get that from. Where they really get it from is if it said 5x to the power of 2, they would have said 5 squared x squared. The big difference here is between the 5 and the x, they were being multiplied, right? They were being multiplied. Here, those 5 and those x, they're not being multiplied, right? So that's why that misconception exists is all I'm trying to say. And so let's talk about how are we going to go about this. And once again, you may label this as method 1 and method 2. Method 1 is the one that I need you to learn very well, and method 2 is the backup that would have been acceptable completely if you were an Algebra 1 student, okay? So in method 1, what you have to learn is called the square of differences formula, okay? It's called the a minus b whole squared formula. Whereas method 2 is once again your FOIL method. All right. So let's talk about the square of differences formula. The square of differences formula, it's once again expected that students generally tend to know this. And basically here is the idea. It says that let's suppose that you have a and then it's subtracting b. Right, subtracting b, and then that is to the power of 2. So that's why we call it the square, right? There's the square right there of differences. So first you do this, right? So first you find the differences, and then next you square it. So that's why we call it the square of differences, right? Well, automatically, first off, let's talk about the misconception. So I think I just discussed this misconception with you, so you understand that you're not going to do that anymore. All right, you're not going to say that a minus b whole squared is a squared minus b squared, right? So that's a common mistake students make. But more than that, what you want to realize is basically the end result of it goes like this. You take the first term, right, the first term, which is an a, and you square it. You take the second term, which is a b, and you square that. And finally, the middle term is going to be minus 2 times ab, right? Minus 2 times ab. So that right there is called the square of differences formula, all right? You have to memorize it very well. When I was learning math, I learned this early on. I learned it maybe in 6th grade, but I found many Salam School students are not very comfortable with it. They may have learned it, but they just haven't used it on a regular basis. So while we're here, curiosity is there a square of sums formula, right? And the reason why it's a curiosity is because earlier we talked about a difference of squares formula, right? And then I said there is no such thing as a sum of squares, right? There's no sum of squares formula. So if there is a square of differences formula, is there a square of sums formula, right? So there's a difference between the two. And yes, there absolutely is a square of sums formula. And so what we're saying is you're going to square, or you're going to square the sums. You're going to add up two numbers and you're going to square them. So that's why it's called the square of sums. It basically resembles the formula that is for square of differences. There's basically only one difference between them, and the difference is right where I'm highlighting for you. When you have a square of differences formula, there's going to be a subtraction sign on that second term, and when you have the square of sums formula, there's going to be an addition sign on that second term. That is the major difference between those two. All right. Now, I know that the words tend to confuse people, so let's just back out a little bit and talk about this one last time before we try a handful of questions. Is the top one says difference of squares, right? Difference of squares. And essentially what it's really doing, this is quite rewarding to think of it this way, is it's really taking a plus b and it's multiplying to a minus b, all right? The second one, which is called the square of sums, that's almost like the odd one out, but that one is more like a plus b times a plus b, because it says a plus b squared, right? And the square of differences is really a minus b times a minus b, all right? So what I'm trying to explain to you is they are three different things, right? There are three different things. I know that one of them, this confuses people, but I know one of them is used in the backwards order, whereas the other two are used in a more forward order, right? But that's just how we tend to encounter them in mathematics. But there you go. Those are the three formulas that you need to know by heart, and you need to know them quite well. So let's go back to the question that we were doing, and we were talking about a minus b whole squared, right? So now we call this the square of differences formula is one thing we know. So we know that whenever that situation occurs, you're going to have a squared minus 2ab plus b squared as your answer. So having said that, in number 50, when it said x minus 2 whole squared, according to method 1, what we'll do is we'll square the first term, so that's x squared. I'll put a parenthesis around it. And then we'll put a subtraction sign because there's a subtraction sign right there. So you put a subtraction sign right here. And then you put the number 2 multiplied by the first term multiplied by the second term. If you're wondering where does that subtraction sign come from, by the way, it really came from the second term. So don't double write the negative. Don't write the 5 with a negative when you already took care of it by putting a subtraction sign right there, right? And finally, the square of differences formula says, then take the last term and square that. And so like this, we have completed this little exercise, and you simplify it as you can. So this becomes minus 10x in the middle, and that becomes a 25. and that is where you stop. You may look at that and be like, can't you factorize that? So that's going to be the second part of the lesson, right? We're going to talk about how could you factorize this, right? Now, while we're here, the method 1 is the one that's desired and you need to know it. What's the other way that students do it, especially students who are forgetting that formula on the spot, is they write out x minus 5 twice, and then they say x times x is x squared, x times negative 5 is negative 5x, negative 5 times x is negative 5x, and then negative 5 times negative 5 is positive 25. Then they combine those two middle terms, and it looks like the following. So when they combine those two middle terms and it looks like the following, notice how that is exactly the same as this before, right? But recall the same message that I gave to you in this previous example in number 50. Oops, sorry, not in number 50, but there was another example that I did. I just want to scroll up there and talk about it. So in number 48, that message that I gave to you about using those methods that are going to save you time. When you have a lot of questions to do, you're going to need these methods. As much as you may want to hold on to the old method, it doesn't really quite cut it for you. You start losing a whole lot of time as you're going through them. Number 52, we certainly want to try number 52 because it adds another thing that I can talk about often confuses students. So you have 3x minus 4, and it is squared. First off, what I want to tell you, and this is what confuses students, the first term is a 3x, okay, and the second term is a 4. It's not like just the x is the first term. So the first term is a 3x, the second term is a 4. And now I'm not going to do method 2 here, okay? I'm leaving method 2 alone. As it is, you probably know how to do it from before anyway. So the only method that we really do is the one that is needed for you to learn, right? So we're going to be using the a minus b whole squared formula, which I've written for you already. So we're just going to go ahead and move this forward. So using the same exact idea, realize that a is 3x and b is 4. And so I start writing into that formula. So it says the first term squared, so 3x whole squared, minus 2 times the first term times the second term, and then added to that second term squared, like this. All right, and then really quickly simplify it. 3x to the power of 2 is not simply 3x squared, it's actually 9x squared. And then 2 times 3x times 4 is going to give you, bismillah, negative 24x. And finally, the last one is 16. So this is your final answer. All right, this is your final answer. Again, the second method, by all means, you may try that. But you're upper level students now, so you need to be able to move on from that as quick as possible. All right, so now what we're going to do is we're going to take number 56, and we're going to try number 56 twice. Basically, I'm going to give you two examples here. So they're designed like number 56, not necessarily just 56 itself. And so the first one that I'm going to do is I'm going to do a question about 3x plus 2 whole cubed. And then I'm going to do another question for you, and that's going to be 3x minus 2 whole cubed, right? So this part right here is known as the cube of sums formula and the difference of sums formula, right, or the cube of differences formula. So where exactly do those two stand? I just want you to see them. So the cube of sums formula is right here, and the cube of differences formula is the one right below it. Again, for your convenience, I have made a little sheet for you that, again, like I said, I posted on the website. I've linked in this lesson just so you can take a look at it. But I would really recommend that you practice writing this by your own hand as opposed to just having it there. So we're going to be using these two formulas to simplify some expressions for us. Okay, so I'm going to keep these with me. Let me just try to get rid of this cursor here and try that again. So I'm going to keep these with me, and as I go through these two questions, you want to take a look at how I'm putting it together. One thing I'll say before I move on and try that example is notice how there was a square of sums formula and there was a square of differences formula. Now there's a cube of sums and a cube of differences, so that's already adding a lot more for you to learn. But then at the same idea, if you had a difference of squares, you can actually have a difference of cubes. That's crazy, right? And there is no such thing as a sum of squares, but there is something such as a sum of cubes. So these are all special products and you have to learn them, all right? As painful as it may sound, you do have to learn how those things actually work for you. So let's go ahead and take a moment and try these questions over here. I'll just move this down a little bit so that we can fit those two formulas that I just copied into this section, and then we'll be looking at them as we move forward. All right. So here is that section, right? The one that's relevant to us. So basically, for number 56, the first part that I'm trying to do for you, one thing that you are welcome to try, okay, one thing that you're welcome to try is you're welcome to take 3x plus 2. You can pause this video. You can take 3x plus 2 and multiply it by itself 3 times. All right, so you can multiply it by itself 3 times, and you can take 3x minus 2 and you can multiply it by itself 3 times. And you should end up with the correct answer, by the way. All right, but you want to refrain from doing that in pre-calculus because it will take you a lot of time, and time becomes a huge factor in upper level mathematics. All right, so if you're wondering how exactly would you have gone about this, you would have basically used the FOIL method on those first two, or the a plus b whole squared method on those first two, your call. And then whatever result you get, then you would multiply that to this right here. And in that same vein, you could have multiplied these two using a minus b whole squared or the FOIL method, and then multiply those to those two over there. So you can pause the video and you can try these by yourself, right? You can try these by yourself and see what you actually end up with. Now what I'm going to do for you is I'm going to take the moment. I'm actually going to show this to you the long way, all right? So here goes. I'm going to take 3x plus 2 and multiply it by 3x plus 2, and I'm going to end up with, using just the FOIL method, just a basic method for you to be convinced of this, I'm going to end up with 9x squared plus 6x plus 6x plus 4. So that's what I get when I multiply the first two. But then the question says multiply by 3x plus 2 further. Before I do that, please realize that that middle term is going to combine, and this is what we're going to have, like this, right? But moving it forward, now I got to multiply the 9x squared to the 3x, which gives you 27x cubed. And then the 9x squared to the 2, that gives you 18x squared. Then the 12x to the 3x, and you get 36x squared. And then the 12x to the 2, which gives you 24x. And finally, 4 times 3x is going to give you 12x. And 4 times 2 is going to give you 8. And it's still not finished yet. It's still not finished yet. You can combine these two terms right here. You can combine those two terms right there. So it gives you 27x cubed plus 18 plus 36 is going to give you 54x squared. And then 24 plus 12 is going to give you 36x. And finally, add 8. So I'm going to leave this result up here. Okay, I'm going to purposefully leave this result up here just so that you're convinced that that does work. But the amount of work, I'll say this one last time, that's going into this. Actually, you know what? More like all of this work right here, that is too much. Okay, it's too much, and we don't have that kind of time to be investing into a process like this. All right, so we're going to take this entire piece, and we're just going to kind of move it down a little bit. All right, we're going to move it down, and I need very little space to actually apply the formula. So we're going to go ahead and use the cube of sums formula. The first thing that you want to do is you want to jot down that basically in this situation, a is going to equal 3x. So a is equal to 3x, and b is equal to 2. and you want to just observe how the sign between them is a sum sign. That's why we're going to be using the first formula as we begin. All right, so let's go ahead and start. The formula says that whenever you have something that is of the format a plus b cubed, here's what you do. All right, here's what you do. The first thing that you do is you take the first term and you cube it. Okay, so what was the first term? That was the a term, and so 3x whole cubed, right? Then it says take the number 3, so 3, multiply by the first term squared, so 3x squared, and then multiply by b, which is that second term, so multiplied by 2. All right, let's keep moving. And then it says that take the number 3 again, and this time multiply by the first term, and then multiply by the second term squared. There is a pattern here if you're wondering, and I'll show that to you in just a moment, all right? And finally, the last term is 2 to the power of 3, all right? Now, here is the pattern. Notice that we began with 3x to the power of 3, and then we went to 3x to the power of 2. And then we went to, think about it, we went to the 3x to the power of 1. And the last term, there's 4 terms here, 1, 2, 3, 4. Notice how the last term doesn't have a 3x, right? And the reason why algebraically doesn't have a 3x is because really there was a 3x to the power of 0 right there, and the highlighting goes on the 0, but anything to the power of 0 is 1, and that's why you don't see it, right? So we try to keep this formula as succinct as possible. That's why we don't put a to the power of 0 on this end. And so really it goes in a pattern. It goes 3, 2, 1, 0 as far as the exponents are concerned, right? So I'm just giving you some ways to help you memorize that formula. And then by the same token, take a look at the second term, right? It says 2. And if you think about the 2, it's got a very similar structure, right? It's got a very similar structure. The second term has a 2 to the power of 1. The third term has a 2 to the power of 2. And the fourth term has 2 to the power of 3. And by the same logic, on the left end, completely on the left end, really what was there was a 2 to the power of 0, but we don't bother to write it because 2 to the power of 0 is actually 1. So what I'm trying to say to you is it's a way to help you memorize a pretty difficult formula. You go a cubed, a squared, and then a to the power of 1, while at the same time you're going b to the power of 0, b to the power of 1, b to the power of 2, b to the power of 3, like that, right? So one of them is going up, the other one's coming back down. And you always start off with the number 3 in this situation. So that's just a way to help you memorize the formula, but let's go ahead and finish up with this question. The first term is going to be 27x cubed. The second term will be 3 multiplied by 9x squared multiplied by 2, which when you simplify it, is going to give you 3 times 9, which is 27, times 2, which is 54x squared. So that term gets simplified. The first one, there's not much to do with that right now, so 27x cubed. The third term is going to be 3 times 3x, right? 3 times 3x, because 3x to the power of 1 is simply itself, times 4. And so when you put that one together, you end up with 3 times 3, which is 9, times 4, which is 36. So 36x. And finally, the last one is 2 cubed, and 2 cubed is 8. Okay? So if a person knows the formula, they straight go from looking at the question, right? The question is 3x plus 2 whole cubed, and they go straight to the answer, which is the thing in the box, right? That can be managed. Now, while we're here, I just want to convince you that this does work. Take a look at the answer from the long method of doing this question, all right, and take a look at the answer from the short method. Initially, what will seem to you is, no, this is the longer method, but that's only because there's an initial struggle with knowing that formula, but after some time, you get quite used to it. Well, let's try the same exact exercise again, and this time what I want you to do is pause the video, and I want you to try this situation right here, okay? I want you to multiply 3x minus 2 times itself 3 times and see where that actually takes you, all right? and then we'll discuss a formula that actually works incredibly to our benefit in this situation. All right, so now what we're going to do is we're going to go ahead and try 3x minus 2 whole cubed. And one of the reasons why I ask you, right, initially I told you don't use the long method. The reason I asked you to do this is because most of the time you've never seen this formula before, so you want to just be convinced that it does work, right? So let's go ahead and give this a shot. 3x times 3x, it begins very similar to that previous question. It's going to give you a 9x squared, right? And then 3x times negative 2 is going to give you negative 6x. Then negative 2 times 3x, so we're doing only this part first, right, is going to give you negative 6x again. And finally, negative 2 times negative 2 is going to give you negative 4. Now that is going to be multiplied further to 3x minus 2. Now when you do that, it's going to give you 9x squared minus 12x minus 4. And that is multiplied to 3x minus 2. Now you go ahead and you start multiplying each one of these three terms to those two terms as we did earlier. So here's what you should end up with. You should have 27x cubed as your first term, and then you should have negative 18x squared as your second term, and then you should have a negative 12 times 3, which is negative 36x squared as your third term, and then positive 24x as the next one, and then negative 12x, and then finally positive 8, right? Now let's go ahead and combine those terms that we were looking at. When you combine those terms, we end up with 27x to the power of 3 minus 54x squared plus 12x, right? And then plus 8. Let me just check one thing. I have a feeling that this 12x, this 24x might not be, or the 12x might not be correct. So let's just go back to where we found that 12x. We did negative 4 times 3x, which is negative 12x. That's good to go. I see where I made a mistake, so just kind of correct this really quickly. I'll put it in red. That's supposed to be a positive 4 and a positive 4, because negative 2 times negative 2 gives you a positive 4 right there, right? So when we talked about 4 times 3x, that was actually a positive 12x, all right? So a positive 12x. And then when we talked about 4 times negative 2, 4 times negative 2 actually gives you negative 8. So apologies for that, but there you go. That corrects it. So when we ask what's 24x plus 12x, 24x plus 12x actually gives you 36x. Okay, so there you go. I apologize for that. But this, and you know, I think there's a very good lesson in this, by the way. Look at how much error there is, even for a teacher, to make mistakes with if they're using this long method of going about it. Okay, so I guess, you know, that happens for a good reason right there, is you kind of notice that, all right, there's a way to go wrong with using that long method of doing things, right? Now what we're going to do is we're just going to place this next to the old one. And one thing you guys will notice is the only difference between a minus b and a plus b cubed is the fact that the symbols, right, the symbols are swapped around. Whereas you had plus, 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 now you have plus, minus, right? So that right there. And look at the highlighting, right? Look at the highlighting right there. And before I do this with the formula, I just want you to realize something more than that. Is back when we were looking at those formulas, notice that it was the same thing. When you had a plus b whole squared, it went plus and plus. When you had a minus b whole squared, it went minus and then plus. And the whole logic behind that is the first term is positive, the second term is positive, the third term is positive. In this situation, the first term is positive, the next one is negative, the next one is positive. So when we talk about the cube of sums and the cube of differences, obviously in the cube of sums, everything is positive. But in the cube of differences, the first term is positive, the second term is negative, the third term is positive, and the fourth term is negative. So they keep doing something called alternating signs, right? So they keep alternating signs. That's another way to keep track of this formula and make sure it's working for you. Okay, now let's go ahead and take a moment and actually try this question using the proper method of doing it now. And so first off, a is equal to 3x and b is equal to 2, right? So that's exactly the same thing that we said earlier about the cube of sums formula, right? That's not much different than before. So let's go ahead and try it. We'll have the formula that we copied earlier, right? So let me bring that formula forward. We copied a formula that's going to be very useful to us, which is known as the cube of differences formula. The best way to memorize these, I'll be honest with you, is just keep writing them, and eventually it does settle in for you. So this one will go a little bit quicker with 3x to the power of 3, so that's the first term cubed, then a subtraction sign according to the formula, subtraction sign, then 3, and then that first term squared, so 3x squared, and then multiplied by b, which is simply 2. Then put an addition sign, right? Put an addition sign, and then go 3 multiplied by 3x to the power of 1, and then 2 to the power of 2, and then finally the last term is 2, and you cube it. All right, so really quickly, we've done this before already. So 27x cubed is what we get out of that first one. The next one is 3 times 3 squared times 2, which is going to give you 54x squared. And then the next one is, I'm just giving that space so I can write them underneath. And then the next one is going to give you 36x, and the final one is going to give you -8, right, or -8. So once again, feel free to compare the quick way of doing it to the longer method of doing it, and you'll realize that you get the same exact answer. Okay?